All right, in this lesson, we're going to write the point slope form. So write point slope form of a linear function given a graph of its solution. So given a graph of solution. So we're going to be given a graph, and we will write a linear equation for that graph in point slope form. So let's review point slope form. Well, let's keep this consistent with the other video. So m will be the slope, also known as the constant rate of change. Constant rate of change. I don't know why that looks so weird. Okay. Then remember, this will tell us how we move, or it's useful to think about it as how we move. And then we will have an x1 and a y1. We will have a solution, x1 and y1. And remember that this point will look opposite of what it is because we're subtracting it. So if it's positive, when we subtract it, it'll look negative. And if it's negative, when we subtract it, it will look positive. So point slope form. Let's go ahead. We need we for sure need the slope and some points. So let's go ahead and label some points first. So here's one right here, one right here, one right here. Remember, there's actually all these are points. We're just picking the nice integer ones. So let's go ahead and figure out what the slope is. Up to right 3. Up to right 3. So the m is up to right 3. So that's a positive over a positive, which is a positive. So right away we can put 2 over 3 as our slope. And let me use green. So, well, you know what I'll do? I'm going to make these points pink, just like I labeled the point over here. So we need to make that x, and then we need to put y here. So let's pick a point. It doesn't matter which one. I'm going to label these -6, +1. This is -3, +3. I'll put it right here. -3, +3. This is 0, 5. And this one is 3, 7. I want you to remember that point slope form, these are going to look the opposite, okay? So it doesn't matter which one we use. Usually we stay away from the y-intercept, the 0, 5, just because it's just convention that you don't usually use the y-intercept for point slope. So let's use these other ones. So we have -6, +1. So -6, +1. I'm going to put that in the corner here. -6, +1. So even though it's +1, we're going to take it away, so it's going to look like subtraction. Oh, that was my bad. This 6 is the x, -6. So even though we're subtracting, even though it's a -6, if we subtract it, it will look positive. And for the y, which is 1, even though it's a +1, if we're subtracting, it's going to look like a negative. So -6, it's going to look like +6. 1, it's going to look like -1. All right, let's do the -3, 3 here. And the 3, 7 over here. And we'll just go ahead and put it all in blue this time. So y, and then we have a 2/3 x. Okay, so the x is negative, but which means when we subtract it, it will look positive. The y is positive. When we subtract it, it will look negative. And just so we know, I'll say that one's there, that one's over there. All right, so let's do this. and right here. So this x is a positive. When we subtract it, it will look negative. This y is a positive. When we subtract it, it will look negative. Okay, cool. So let's use one of these. I like this one. So y minus 1 equals 2/3 times x plus 6. Now, I use -6, 1 for this. So I'm going to use a different form. I like this one, 3/7. So I'm going to use 3/7. So 3 goes here and 7 goes here. So -1 equals 2/3 times 3 plus 6. Oops. Yes, we used that one. That looks like a B, but it's a 6. Okay. Maybe I should just draw that a little better. And I can fix this one. Okay. I don't know why I keep making it worse. Okay. And we get 7 minus 1 is 6. And 3 plus 6 is 9. And 2 times 9 is 18. 18 divided by 3 is 6. My 6s just look weird, right? And 6, in fact, equals 6. Now let's look at the second page. Ooh, so this time we have a table. This should be easier in a few ways. But let's go ahead. We need the slope. We need the slope. And we need some points. So we need some xy's. So right here we can do negative or minus 1.5. Oh, I should probably change in y, change in x. Okay, and this is plus 2. And remember, it's linear, it's constant rate of change, so whatever I do is going to be the same. I guess I should attempt to write this as a fraction. So a negative, well, I guess I should write it as a fraction. So negative 1.5 over positive 2. A negative over positive is a negative. I can make this look a little bit better. So negative 1.5 over 2. Now we got to turn this into, I don't know, just not this weird decimal. You can use decimals. It'll give you a fraction with no decimals. I can get rid of this decimal though if I multiply by 2. Remember, you can use Desmos, but I don't want to switch back right now. So that's negative 1.5 times 2 is 3. 2 times 2 is 4. Remember, once again, you can use Desmos or any calculator to do it if you want, or you could just change the decimal 1 into a whole number 1 and you should be fine. So we get negative 3 over 4. And I'm going to choose, I don't know, any of these really. So 10, 92.5. I'll use that one. 10, 92.5. So I'm going to write the rest of this like this. Y and then X. So this 10 is a positive. When I subtract it, it will look negative. This 92.5 is a positive. When I subtract it, it will look negative. There we go. It was a little weird, but it'll be fine. And let's use 695.5 here. Ooh. And 1092.5. As you see, there is room for you to go backwards in the table to create more values. You don't have to. You could. Like if you're looking for like regular whole number ones, that's fine. But so let's go ahead and put negative 3 over 4 times x. And then that looks like a positive, so it'll be negative. Well, that's positive, so it will look negative. That's positive, so it will look negative. Okay. That looks a little squished right there. I'll make a little more room. 0.5. Okay. And lastly, we have one right here. So negative 3 over 4 times x, and that's positive, so it will look negative. And that's positive, so it will also look negative again. This one wasn't too bad, actually. Just remember that if you ever see a decimal one, use Desmos if you get this negative constant rate of change or slope. I like... Ooh, I didn't even... Did I use the same one twice? I used the same one twice over here. Oh, man. Okay. Let me try to hurry this up, not to waste too much of your time. So, 497. Okay. So, negative 3 over 4. And we'll put x minus 4. And then this one will be y, that's positive, so it'll look negative, minus 97. Okay, I like this one. It has no decimals. So I'm going to write this in. So y minus 97 equals negative 3 over 4 times x minus 4. Okay. And I'm going to choose one of these others. Oh, 1092.5. 1092.5. Okay, so it's going to say 10 here and 92.5 here. So minus 97 equals negative 3 over 4 times 10 minus 4. Okay, so 92.5 minus 97. Well, it takes 2.5 to get to 95, and then 2 more, so that's 4.5, but negative. Equals negative 3 over 4 times 6. So we get negative 4.5 equals, so a negative times a positive is a negative, so that's good. 3 times 6 is 18. This one I'll show you because it involves a decimal. And negative 4.5 equals, 4 goes into 8 4 times. Oops, my bad. Negative divided by positive is negative. And 4 goes into 8 4 times. There's 2 left over. 2 fourths is 0.5. And looks good. Sorry about that mistake right there. That's it. Thank you.